Welcome to Study Loop.
So here we're going to use equation 1015 for part A, and we can say that we have 60.0 radians, which would equal 1/2 times omega sub 1 plus omega sub 2 multiplied by the time of 6.00 seconds. So essentially, the angular displacement is going to be equal to the average angular velocity multiplied by the time. Knowing that omega sub 2 equals 15.0 radians per second, we can find omega sub 1 is equaling 5.0 radians per second. This would be our answer for part A. For part B, we're going to use equation 1012. So equation 1012 gives that the angular acceleration would then be equal to 15.0 radians per second minus 5.0 radians per second divided by the time of 6.00 seconds. This is giving us 1.67 radians per second squared. This would be our answer for part B. For part C, we're going to interpret omega equaling omega sub 1 and theta simply equals theta sub 1, which equals 10.0 radians. And we can say that the initial angular velocity would be 0 radians per second. Therefore, we can use equation 1014 and say that theta initial would be equal to negative omega sub 1 squared divided by 2 times alpha plus theta sub 1. And we can then solve, and we find that the initial angular displacement is 2.50 radians. This would be our answer for part C. That is the end of the solution. Thank you for watching.